So in this question, we need to find the maximum value of sec inverse, and there is some expression inside it. So let t be that expression which is given inside the sec inverse. Okay. So now to find the maximum value of this term, we need to basically, the question is asking us to find the range, right? So one thing which we can do is find the range of this inner term. Then we'll apply it inside the sec inverse. Then whatever will be the maximum value of range, for example, it belongs from, for example, A to B, right? Then B is going to be maximum, right? Given that the function is increasing. Okay. Okay. Okay, let's see. So T is this thing. So let's try to find the range of T. So now we'll, for simplicity, we'll again substitute x square as P, right? So that we don't have to write x square term again and again. So when I open this bracket, it becomes minus 5p minus 8 upon 2 times p plus 2, right? Then I'll try to generate some term up on the numerator so that it cancels out with the denominator, and then we can get one term which is constant and another term which is either at numerator or at denominator consists the variable, but not at both sides, right? Otherwise we'll have difficulty in finding the range. So for our simplicity, we are breaking down this. We are writing minus 5p minus 8 as minus 10 plus 2, right? We can write minus 8 as minus 10 plus 2, very simple. Why we broke it down like this? Because 5 is a multiple of 10, right? Okay, so we can generate p plus 2 here, and then we can see that when p plus 2 cancels out, we get one constant term as minus 5 by 2, and we get 1 upon p by 2. So we can see there is no variable term on the numerator, only at the denominator, right? So this is going to help us. So now we have to also keep in mind of our substitution, that since we substituted p as x square, that means p has to be greater than equal to 0, because x square is greater than equal to 0, right? All right. So now to find the range of this t, we'll substitute p firstly as 0 to find the minimum term. No, sorry, since it is in denominator, so if we'll minimize p, so we'll get the maximum term, right? So when we put p as 0, we get minus 2, right? And since p can take any value, the maximum value of p can be infinity. So as p approaches to infinity, the denominator term is going to be 0, because it's going to be very huge number which is tending to infinity. So it will become minus 5 by 2 plus 0. So we can see that since at infinity the bracket is the bracket of p, like if I represent it like that, p belongs from 0 to infinity. So when we put infinity, we are having open bracket, not closed bracket, right? So we cannot we cannot include minus 5 by 2. So that we have to take in our mind, that we cannot put as square brackets here, it has to be open. Okay. Okay, then we can write sec inverse t. Okay, so why we are converting sec inverse t? Because we have sine inverse in our mind and cos inverse in our mind. But we converted sec inverse like this because we know that sine inverse is an increasing function and cos inverse is a decreasing function, right? Since cos inverse is a decreasing function, we need to minimize 1 by t to obtain the maximum value of sec inverse t. So why we are minimizing? Whenever we have a decreasing function, in order to obtain the maximum value of that on any at any x, if we need to find the maximum value of y, so we need to look for the minimum possible value of x, right? So that's why we'll minimize this, because cos inverse is a decreasing function. All right, so now we know the range of t, so we'll simply inverse it. But when we'll inverse it, these things are also going to swap, right? So then we have to consider the bracket again. So when we inverse the t, these things also get swapped their positions. And now 1 upon t is belonging from minus 1 by 2 till minus 2 by 5, right? All right. So now, what our initial goal was to minimize 1 by t, right? To minimize 1 by t. So what is the minimum value? It is minus half, right? So now we'll directly substitute minus half in cos inverse. And since we know that cos inverse of minus theta is pi minus theta, so we'll get 2 pi by 3 as our final maximum value of sec inverse t, right? So whenever there is a bigger expression given inside some bracket, you can always substitute it as a variable like we have done it here, right? T. And then our calculations will be simpler. Our representations will be simpler. So our answer was 2 pi by 3.